Hi friends, today we will discuss the topic of time shifting property. So in time shifting again we have two different topics, which is delaying a signal and advancing the signal. So like we have seen in the earlier sessions, signals are of two types, a continuous time as well as discrete time. So time shifting, the mathematical characterization of a signal in a continuous time is represented as x of t minus t naught, and the discrete time it is represented as x of n minus n naught. If t naught is greater than 0, then we said that this is delaying the signal. If t naught is less than 0, this is advancing the signal. So we will see the pictorial representation of delaying the signal as well as advancing the signal. So let's start with that. So let's assume that we have a signal x of t, and this signal x of t is defined. It's defined between the interval minus t to plus t, and the amplitude of this signal x of t at t equal to 0 is a. Okay, so I'm just writing it mathematically. X of t is defined for t greater than minus t less than capital T. Now time shifting is defined as x of t minus t naught. I'm assuming t naught equal to t. Assume t naught should be greater than 0 for delaying the signal. So I'm assuming t naught equal to t capital T, which is greater than 0. So now this is defined as x of t minus capital T. So now we know for x of t is defined within the interval minus t to plus t. Now we have to define a new timeline, and we have to find a region. We have to find the region in the new timeline for which signal x of t minus capital T exists. So to do that, what we have to do is we need to define a new timeline, right? X of t minus capital T. So wherever you find t, just replace it by t minus capital T. So I'm just replacing by t minus capital T. This is minus t. Again, wherever I find a t, I'll just replace it by t minus capital T. So this t, this is nothing but 0 less than t. So now this, you can see the signal x of t minus capital T. So this signal is defined in the interval for t greater than 0 less than capital T. So I'm just defining the same signal. You can see here. This is x of t. This is 0. This is t. So this is 2t. I'm sorry. This is 2t. And this is 2t. Okay. Now whatever you find at minus t, the same signal will get now reflected to 0. Whatever you find at 0, you can see at 0 the amplitude of signal is a, will now get reflected to t. Whatever you find at capital T will now get reflected to 2t. So I can just draw the signal x of t minus t as this is x of t minus capital T. So now you can see here this signal is just shifted by t units towards right. Towards right, the signal just shifted t units towards right. This is capital T. This signal just shifted t units towards right. So I can say that when t naught is greater than 0, so I'm assuming t naught equal to capital T, which is greater than 0. In this case, we say that signal is right shifted. Right shifted by how many units? Say right shifted by t units. So this is a case of right shifting property. You can say this as right shifting or delay. Why? A signal got delayed by t units. A signal which was existing, the amplitude of a signal at t equal to 0, it's A. Now this amplitude, now you can see here, this signal got shifted to by t units, got delayed by t units. So I can call it as a delayed signal. Now we will see advance. Advance or left shifting property. We will take the same example. I have a signal x of t which is defined between the interval minus t to plus t, and the amplitude of a signal at t equal to 0 is A. So now I'm assuming x of t minus t naught. Now we have to see a diagrammatical representation of x of t minus t naught. When t naught is less than 0, it is advance. When t naught is less than 0, so it is advance. I'm just writing it as x of t plus capital T. T plus capital T. So here t naught equal to minus t, which is less than 0. X of t minus t naught equal to x of t plus capital T. Here by comparing this expression with this, t naught we can say this is nothing but minus t, which is less than 0. So now we have to define a new timeline. Similar, like x of t is defined for the range of values of t. Range of values from minus t to plus t. Similarly, we have to define x of t plus capital T. So we have to define a new timeline for which this signal exists. We have to find a new timeline and we have to find the range, interval in, between which this signal exists. So now we will define a new timeline here, capital T. I know that x of t is defined for t greater than minus t less than capital T. Now we want x of t plus capital T. X of t plus capital T is defined between minus t less than, just replace wherever you find t, just replace it by t plus capital T. T plus capital T less than t. So this is nothing but minus 2t less than t less than 0. So now we can say that x of t plus capital T is defined between the interval minus 2t to 0. Between the interval minus 2t to 0. Now we will draw the signal. Whatever I find at t now will get shifted to 0. Whatever I find it at 0 will now get shifted to minus t. Whatever I find it at minus t will now get shifted to minus 2t. Now get shifted to 2t, minus 2t. Amplitude of the signal is A. This is x of t plus capital T. Right? So this signal, it is left shifted by capital T units. See here, the amplitude at t equal to 0 is A. Now the same amplitude is it's existing at t equal to minus t. So this is left shifting property. So advance and left shifting property. So now we have seen a time shifting as well as advance property. Now we will see time reversal property. Pictorial representation of time reversal property. and it is represented as x of minus t in the continuous time case, x of minus n in the discrete time case. Okay, so it is defined as x of minus t in the continuous time case, x of minus n in the discrete time case. Let's assume that we have a signal, say x of t. Let's assume that we have a signal, say x of t. Instead of taking this example, because it's an even signal, so we will take another example. Okay, we will take this example. This is x of t. Okay, this is 0 and this is capital T. Okay, so now I can say that x of t is defined for t greater than 0, less than minus t. All I need to find is x of minus t. So wherever I find t, just replace it by minus t. X of minus t is defined. Wherever I find t, just replace it by minus t, less than 0, less than minus t. Sorry, this is plus t, so this is t. So now I can say that this is defined for t greater than minus t, less than 0. For t greater than minus t, less than 0. Now I can just have a diagrammatical representation of this. I can just give a diagrammatical representation of this. This is t. And this is minus t. This is minus t. X of minus t. This is a signal. Now we can see that we know x of t is defined for t greater than 0, less than t. When if a question has been given to find x of minus t, all you need to do is you need to define a new timeline. And you need to find a range of interval for which this x of minus t is defined. In order to find that, all you need to do is just replace wherever you find t, you have to just replace it by minus t. So now you got this is minus t greater than 0, less than t. Now doing a mathematically it is expressed as t greater than minus t, less than 0. So now I can say that x of minus t is a signal which is defined for t greater than minus t, less than 0. So this is nothing but folding the signal with respect to y-axis. If I fold the signal with respect to y-axis, what I get is x of minus t. Folding or reflection. We also call time reversal as folding or reflection. So this is the time reversal property. If you like the videos, please subscribe and share my channel to your friends. Thank you.